Hello and welcome everybody to another show where we're talking about innovation. And today we're going to be talking about machining and manufacturing, or in particular, we're going to be talking about CNC machining. So we'll get a little bit into that, what that involves shortly. The reason I wanted to talk about manufacturing and machining today is because there's a lot of challenges in the engineering and manufacturing industry at the moment, as there are with a lot of the industries, with cost cutting, challenges in resourcing, getting things on time. So I wanted just to talk to somebody who is an expert in this field and has a lot of experience. So on that, I'd like to introduce you to Mike Coutts. He's the director of Wellahead Engineering Ltd, and he's going to be talking to us today about some of his experiences and some of the things that he's seeing going forward. So welcome, Mike. Thanks for joining us.
Thank you.
So just to kick things off, I said we're talking about machining and CNC machining. For some of those people who might not be too aware of what CNC machining is, or what the different 2, 3, and 5 axis machining involves, do you want to just give us a bit of a background as to the sort of machines that you have and the facilities, and what CNC machining actually means?
Yeah, certainly, Carl Matthew. Welcome, folks. I'll give you an introduction. I'm obviously a director of Wellahead Engineering. I have my own business for over 22 years now, and we predominantly machine components, repair, from manual machining to CNC machining. We do inspection services, reverse engineering, and we are renowned for a quick turnaround jobs we do as well, just to keep everybody happy with the customers. As for CNC, we have 2, 3, 4, 5 axis machines. 2 is pretty basic machines on 2 axis, and then obviously you go from 3 to 4, which is obviously just adds another axis to the machine to be able for you to make desired shapes or complex parts that manually you couldn't even achieve. So it is all programmed through AutoCAD or EdgeCam, any specific programming system to put these on the machines. And obviously, we can produce a lot of complex parts from that. And we've got a range of machines, whether it be lathes, milling machines, about 5 axis, as I said, which is obviously one of our top machines we've got. We're hoping to add another one to it, and we're trying to get into the market of 5 axis machining going forward. Obviously things are tough at the moment, so any assistance with 5 axis machining would be great. If anybody's got anything out there I want machined. We've got the full inspection facilities as well, so we can go from raw material right through to the finished product. As for machining, if there's anybody got any questions, you can ask me on it. But it's very complex. Once you go into CNC, there's a lot of different aspects of it that we are passionate about. We've got a lot of people on board here that are 30, 40 years experience machining. So it is a good bunch of guys we've got here working as well. But they're here to, like we're on about, obviously getting opportunities to get more people into the industry as well, which I think we're lacking. Yeah,
that's a good point. I mean, if we look at, I suppose, the progression of manufacturing and machining over the time, CNC, which is computer numerical control. So as you said, it's using an AutoCAD or computerized drawing to actually map out the route that the machine's going to take. So that's something that's added a lot of functionality and versatility to machining over the years. And now going from 2, 3, 4, and 5 axes, so we're getting a lot more angles and directions that the machines can actually move along. So that's been some of the bigger changes, but now we're seeing things like the 3D printing, additive manufacturing coming along. How do you see some of these new changes in technologies helping manufacturing, because it's all machining in particular? Are you seeing much change?
I think the 3D printing is a great idea, and obviously Andy's here to support that. And we have seen some 3D printing products come into us, obviously for final tweaking. But it is amazing to what you can produce from 3D printing, because sometimes you can't always manufacture what you put on paper. So to do that, and we've come across it many times. Years ago, obviously 3D printing would have been great back in the 80s or 90s, but some of the things, some of the drawings we get, like how are we going to make this? So I think the 3D print is a great thing, and I think machining running alongside 3D printing is a great thing as well, because we can add tweak other parts to the 3D model or whatever to assist the manufacture. And I think it's a great thing. It's going to run alongside machining as well. Machining will never die, but I think the 3D printing going forward is going to be a great thing for manufacturing.
Yeah, and as you said, it's about assisting, isn't it? So you've got machining, as you said, it's not ever going to die. Machining is going to get more functions available to it, maybe, different profiles that you can do, but it's never going to be able to do the things that 3D printing can do. And 3D printing is never going to be able to do the things that machining can do. So for most applications, machining is the better method because it's cheaper and faster and, but better for mainstreaming. But the 3D printing working alongside it is where you're going to benefit. And the collaboration that you're going to have with working through some of these other companies, are you seeing that collaboration improve with some of the different technologies?
Yeah, some of our customers are coming with 3D models that obviously they can't get the whole specific thing made. So they are coming to us, say, like, can you add a hole here or whatever? And I think it's it's the first I've seen it. I really need to come and see Andy, what he's actually got, to see what they can produce, because it's not a thing I'm up to speed on, but I think it's a great way forward for manufacturing.
Yeah, and I think that point you made about understanding what 3D printing can do is also typical for a lot of the manufacturing. So do you want to maybe just explain a couple of the main types of items that you machine? So what are your typical parts that you get in? What sort of equipment do you have to use?
We do a lot of wellhead equipment, downhole tools, so we can range from maybe 2-inch up to 30-inch diameter. So the range of machines we've got is excellent, and intricacy as well. And obviously with the different axle machines we've actually got, we can obviously produce complex shapes. And also now a lot of customers are sending us like step files, which we can just download the drawing straight into our programming system, and then it'll generate more for the 5-axis work. We can generate a program from that rather than us having to draw the whole thing. So the step file is a great thing, and obviously that it draws every feature on that of the part. So, but no, we do a big range of, like I say, we go up to like 30-inch diameter, and for the size we are, what we offer, I think it's a great facility we've got here, and obviously looking to add to that. But obviously with the current situation, it's on hold at the moment. But
yeah, so do you find that the quality of the designs and the drawings coming to you now with some of these improvements in technologies is actually improving itself? Like you mentioned step files, whereas once upon a time you would have got a hand drawing where you then have to convert.
Yeah, it's definitely, you would spend hours programming. So this can just be uploaded onto the system, and then obviously a program generated from that. Yeah. And it's a great assistance to a machine shop to get these, be able to manufacture it. So, and we're still trying to get up to speed of the 5-axis, because some of the items we are getting, we haven't had enough 5-axis work on it to get up to speed on it. Like we're doing some trials at the moment, so now that we're quieter, we're getting time to look at it, because there is a lot of things in there that we are not aware of, and it's a whole new dimension for some of these guys here working here. So they're on 5-axis, which is a great thing, and it's just a learning curve and getting somebody up to speed on that.
Do you think it's the designs coming to you that people aren't understanding exactly the full functionality of 5 axes versus a 3 axes, and that's why it's not as popular still?
Oh yeah, definitely. Yeah, it's definitely the way forward. And like I say, they are understanding that we need to go this way, 5 axis. And the other thing, which is the cost saving thing, is like we've do some jobs here. We'd have on 3 machines to get it actually made. Now we can just put it on a 5 axis, do maybe 4 operations in one. So there's a cost saving there. And the more and more, and I think more and more people are looking at machines that can cover a lot more work. So you don't have extra machine, like obviously I've got 3, 4, 5 axis machines here. I could probably replace half of them with a 5 axis machine, whether it be turning or milling. But then it's obviously a big investment for all these things. And I think this is the way forward for machining. People are looking at different types of machines and their capabilities.
Yeah.
And we need the technology and the programming to go with it.
And so the education of the people who are coming to you, knowing what your capabilities are and saying, right, I've got this design. There's no point doing this on the 5 axes because I know it's only a fairly simple flat piece, or you know, I know what the full capabilities of 5 axes is, so I've designed my part suited, ready to go, and that makes your life a lot easier too.
Oh yeah, definitely. Yeah.
So you mentioned there about the costs and spending and that as well. Obviously, it's pretty widely spread that some of the larger companies are driving down cost-cutting requests. 30 or 40%.
Yeah.
In some cases, they're saying to some of the suppliers, fabrication yards, saying cut 30% before we'll even consider talking to you. And obviously, that has its own implications. How do you cut 30% off an already tight margin? And I think a lot of that's going to result in people outsourcing to some other countries or remotely as well, which is going to have its own challenges. So how do you see that that's affecting the industry and companies of your sort of size?
It's affecting us big time. Obviously, back in 2014, the last recession, all the fat was cut out then, prices were reduced. But I think now with the COVID, since COVID, and they're coming out with the 30, 40%, we don't have that markup on the jobs. And it's hard to gauge what price you go in at, because there is people out there just buying the work as well to survive. But
so they're going in under cost, are they?
Yeah, oh yeah, definitely. And we've got skilled men, we've got skilled people, we've got the plant. I don't think people understand the cost of these CNC machines, that how much they cost, to service or run, the power we need to do, the tooling it goes with it, obviously wages, the whole shooting match. And I don't think people understand how much it actually costs to run a machine. And obviously training, there's all this aspects of getting a job out the door. So it is, there's no way 30, 40% is acceptable. And we've had this discussion before with other people. But I think there's just a lack of work there. It will come back, but the 30, 40% is just a no-brainer.
No, and as you say, it's if at the best of times, if you've got a job, obviously it's going to probably go to tender anyway, so you might be making a 10% margin if you're lucky as a fabrication one, which is a pretty generous markup. So where do you get your 30% from? You can't save it on labour. You can't save it on costs of your buildings and facilities and things. Do you cut training? Do you cut quality control? Do you cut your procedure development? That's all going to affect the end user. So, it's not really a viable thing to drive that down solely on the fabrication places, is it?
Yeah, you get for you pay for quality, and that's what you get here. You're paying for a quality job on time, every time, and that's what people forget.
Yeah,
they can go to the guy down the road and get it for half the price, but I can guarantee you the rework would cost more than a job at the beginning. So it's an endless circle there.
I think a lot of that's also based on the cost models, though. So you've got a purchasing department who go on the best price, regardless of what they're going to get, as long as you can supply this part or this machining at this quality or this tolerance, for instance, and whatever the cheapest price is, they'll go for it. But as you say, you go to a company that's 30% cheaper. Where are they getting their savings from? What are they skinking on to get that savings?
No disrespect to buyers, but gone are the day now that the guy you're actually dealing with is an engineer. He's obviously just buying. He could be buying anything. It's just driven, cost driven. And it's been proven with our customers as well. They'll go for the cheapest, even if it's £5 cheaper. They'll go for. Though we've manufactured this part for the last 10 years,
yeah.
they will go the £5 cheaper. So, but no, it's just cost, general costs.
Yeah.
But I think, we need to keep manufacturing in the UK for us all to survive this, and also we need to support each other as well through this current period and going forward as well. It's one thing I keep going on about is just support each other. We're a little town in Aberdeen, but there's so much we could be doing. But I know for a fact there is a good lot of companies are outsourcing to China or India or whatever just to save money.
Are you seeing that more at the moment? People are going outside of the UK, even not even just Scotland to the UK.
Yeah, definitely. And I think the UK's got one of the best manufacturing industries in the world, because we can see stuff coming in from other countries come into Aberdeen. We get reworked stuff that's been made in maybe Romania or whatever, and rework. The cost of reworks, they're back to the same thing. It's all about cost.
Yeah,
it's costing more than reworks. No, I am hearing it from some of our customers that they are getting quotes from abroad, but they're just going to lose the supply chain in the UK, and we need to keep the manufacturing in Aberdeen and UK.
So what do you think can be done to try to help that? Obviously, amongst all of your sort of similar companies, and that you're all talking to each other and you're all feeling the same pressures and things. Mm-hmm. But what can we do to help keep some of that experience? By going outside of the local area, we're not going to get apprentices coming through. We're not going to be able to afford training and development for the people you've already got. We're not going to be able to upgrade facilities and things. So it's going to have a knock-on effect. But a lot of the time, they're just looking at the bottom line, aren't they? As the short term, everybody's feeling this pain, so they need to save money too. So how can we sort of compromise with saving money for them, but at the same time not going to that extreme?
That is a hard one. I don't know. I like to speak to people on the phone rather than emails, and you get the chat going. But I do like to speak to people, which I think is lost now, that just to get a feel and letting them know the passion about how you want to keep manufacturing in the UK. Because, like I say, it's cost driven. So unless the person you're dealing with is into machining and is committed to knowing that he's got a good supply chain there or a good machine shop there, he's going to go elsewhere. And I don't know how we get that across to people.
I think that's exactly the right thing. It's you're going to somebody who can do the job really well. Mm-hmm. And I think the first starting point is understanding what the scope is. What is it that company actually really wants and needs from a machining shop, for instance, rather than just saying, here's the part, I need this done to it. Working with the companies who have got the expertise in and saying, right, is there a better way we could maybe do it? So, the example of a 3 versus a 5-axis machine, can we use it on a 5-axis machine and spend a little bit more cost designing the right path or designing the right process for it, rather than just saying, here's the drawing, go and machine it? So working with that expertise.
But like I say, a lot of these people we're dealing with are not engineers, so they don't know what's involved in machining. And I have invited buyers around to have a look and say, right, this is how we actually manufacture. And like last year, was at the last oil show anyway, we met a customer, and this guy, he obviously purchased a lot of stuff from us, but he wouldn't know one end of a pipe from the other. So it's just educating and trying to educate people how machining is done and what's involved in machining. Because a lot of people just look at look at a drawing, but they've no idea what they're looking at. It's just to get across the work involved to manufacture a specific part.
Yep. As I said, it's about educating people. You know, it's hard at the moment to do those site visits and things, but there's so many webinars and things on the internet at the moment where people can actually spend some of the time learning about the things that they're buying, things that they're designing, what some of the expertises are. And I'm pretty sure that most companies like yourself wouldn't mind somebody ringing up and say, "Can you explain to me, you know, how to do this better?"
Yeah, definitely. But I don't think there's enough of that being promoted for them to actually come and have a look, or even say, like, any chance we could come and see how it's made or whatever. But the interest, I don't think the interest's there for some of them. It's just like, let's buy anything.
Just buy it as cheap as we can.
Yeah. So
yeah,
no,
it's definitely a challenge. I said it's not just the manufacturing machining industry. It's a lot of the other areas as well. So, so we've got a couple other people that have joined us for the call as well. Just while we're talking about this, so people I can see, Andy Simpson from Angus 3D Solutions is 3D printing or additive manufacturing. We've got Chris Hudson there from Blaze Manufacturing, and Katrina Stevenson from Wellahead as well in the business development and marketing. And there's a couple other people without their cameras on. So I'll open it up to anybody if they've got any questions or comments for anybody, Mike or anyone else.
Yeah.
Obviously, I can never resist a comment or a
No, I think you would.
Mike, thanks very much. No, it's great. And yeah, I've got a couple of comments here on a few things you said about the printing and 3D, without the 3D printing. I absolutely agree with you. This is no way this technology will replace machine shops. Machine shops of the future will have a lathe, a 5-axis machine, a milling machine, and a little 3D printer in the corner that might be making jigs, fixtures, tooling, that type of stuff for it. It's just another tool in the armory, you know, and you know, it's people like yourself who see that and recognise that will get the advantage of the technology when you'll start using it for making jigs, fixtures and tooling and that, so that you can keep your 5-axis machine going. Moving to 5-axis, that's a big investment, and I know the machine that you bought is at the top end of that investment as well. So good on you, good to see that, especially in troubling times, you know. And I think it's important because it's harder to get people, it's getting more expensive to have floor space, so having a machine like that where you don't need as many machines because it replaces them, so you don't need so many people or for the training aspect of it, and then reducing your floor space all helps to control the costs. Question would be, is 5-axis, you've been in business 20 odd years, right? Plus, so now you're moving to a 5-axis. Is the main driver of that because the oil and gas components are getting more complex, or is it to open up other opportunities outside the oil and gas industry?
You hit on the head there, Andy. It's definitely there for an opportunity to go into other industries because, like I say, I've been in oil and gas industry for 40 years now, and we've been hit with the same thing every time we get a recession, and it's just a kick in the teeth every time we get for 4 years, and then the carpet's right under our feet. The 5-axis is more to go into different industries for us, and there is oil and gas parts that do need 5-axis, but how big a 5-axis do you need? And it's the same, we're also looking at another machine, probably will be 5-axis as well, but how big do you go? There's no commitment from any customers anymore to say, right, in 2 years or the next 6 months, we need 40 of these and we need a 5-axis machine. It's all about just, like I say, they're shopping around for the cheapest option to get it made. And there's no commitment to any machine shop.
Yeah. I mean, when you're talking about outsourcing and your comment about buyers in general, you know, I totally agree. I think it all boils down to one thing. Nobody wants to build relationships now.
No.
Folk just want to pick up, if you send an email saying, I want this and I want it now. Everyone sees manufacturing as buying an umbrella off Amazon. You know,
Yeah.
you just go online, we send an email, we order it, and it comes on the door. No interest whatsoever. Let's face it, I could go on the internet and buy anything I want, and I don't have to know the first thing about it, because I just pay.
Yeah.
That's the problem. Yeah.
Yeah, it is.
You buy and pay, and that's it. And I think that's one of the biggest issues that we've probably got as well, is that we bring people into the industry, and we as a company, you sit and go, we're in charge, we're the customer, and there's our enemy, the supply chain. Don't tell them too much, don't speak to them too much, and just tell them what we need, rather than, as you say, working closer together and say, actually, this guy could actually help a lot of my problems that I just spoke to him. So I totally sympathise with you there.
Yeah, it's using the expertise, isn't it, of the people who are doing the work.
And it's ignorance from a lot of people that they don't want to take that time out to go and see what Mike's doing and see what added value he's got there. The industry has been asking for innovation for years and years. And here's a guy who's went out and bought a 5-axis machine into the workplace. And it's like nobody really cares. And it is a lot to do with the way that buyers are educated. I mean, I worked at Hydrosun, and people used to phone up us and say, I need a hose. Right? Well, can I send you the details? And they would send you details.
Inquiry for apprenticeships, but also we haven't been taken on the last couple of years. But I think, like we discussed earlier, it's got to be driven from an early age at school, at secondary school, to show them what engineering is all about. So they've got a vision of what they want to do. Because there's a lot of guys out there, they're not academic, they are hands-on people who could actually get a career in engineering. And they're good with their hands, and they will get the support for the learning, the CNC side of it. It all comes, there's so much things out there now for kids, but I think it should be introduced at an earlier age. Like I say, when I was at school, it was metalwork, woodwork, and take-it drawing. And you're saying now, here's your son at school, it's third year before he gets a look at it, and then the next year he's got to choose which subjects he's on. So we're never going to get people interested or got a passion for machining if there's nothing there at the beginning. And there's lots of kids out there.
Yeah, I think you're spot on, Mike. I mean, it's even more difficult in manufacturing within that, because, you know, manufacturing in the oil and gas industry is even harder, because when you've got the industry cycles that's off putting people in to join the industry, and secondly, manufacturing it's not even so much kids. I actually blame the parents, right? I've gone through around schools, you know, and the schools budgets are getting diverted away from the technical aspect, you know, because teachers are driving their kids to go and study something else. So they obviously the head teacher who's got a budget says, well, I need to move, you know, my budget, my money to buy computers rather than a lathe, okay?
Yeah.
And so that's not helping, you know. And you know, obviously I'm on the board of directors for the Angus Training Group, and at one time, you know, when I was serving my apprenticeship, God, it was like hundreds of people you were up against to get an apprenticeship, you know, and now it's a hard sell. It's you're going out to the schools, you're going out to whatever opportunity places you can get groups of kids and saying, you know, are you interested in engineering? Are you interested in manufacturing? They're going, what? No.
Are they interested, or is it just they don't know what it is enough to be interested?
I think there's a mixture of both, Matthew. I think there's a mixture of both. You know, understand it, and you know, I think Mike, doesn't matter what your education level is. There's a job somewhere in engineering, and there's particularly within manufacturing. There's a job somewhere for you.
Yeah, definitely.
If you want a guy, I used to when I was running machine shops, sometimes used to go to the training group, and they would always give you the star pupils. Yeah, and I said, no, I want some down the line, because these are the guys that will come in, work a lathe, and that's
Well,
all they want to do until they retire. You know, the top performers, they want to come in, they want to learn their CNCs, they want to program, they want to be supervised, they want to be managers, and they're away looking for another job because you can't do that. Give them these things. You know, and yeah, it's just getting that across now to kids. It's above average pay as well.
Yeah, yeah.
You know, it's attractive.
Yeah, it's like I say, we've had a good few apprentices, and unfortunately, majority are left, or they gave up the career in engineering. Well, the last downturn, or maybe two downs before, was all driven by money, and the companies were struggling for skilled people. They were poaching each other, and some of these apprentices were getting double the money. I says, but it's not all about getting more money. I says, it's not about more money. It's about an apprenticeship and learning the skills here that you're looking for. I don't mind if you've done your 4 years right, I'm going, but you will get an apprenticeship and the skills that you need. They just, like I say, I've still got my first apprentice, which I think is, and he's he's probably the best guy we've got for quality. He's at his work every day. He just wants to work. He wants to work on machine. He should be my job.
Mm-hmm.
But he's been there. He's committed, and I could count in one hand how many jobs he's got. There's been a rework on it, and obviously I taught him along with the guys here as well, and just an understanding of machining. And he's taken it on board, and he's away. Like he would. It wasn't until maybe 5 years ago that he was on a CNC. He's now programming them. He was always manual. He kept saying, "Oh, can I get CNC?" And now he's on it, and he's away.
Mm-hmm.
But he's got the mindset. He wants to work a machine, and he turns out quality parts. Yeah. And getting some of these people, that's what we want.
Yeah.
I've got a couple of questions here from people in the chat, so I'm just going to read out one or two of them now for you, Mike, and have a think about their answers. So it says here, as you mentioned, every penny is a prisoner. In terms of cost savings, when you're designing parts, what are the main ways to save costs during the machining process? I've noticed in the past that things like surface finish in non-critical areas can be made coarser, which can save on machining time and obviously cost. So there are things that you see when people send you designs. Do you look at them and think, we could have actually designed that better in the first place, rather than you just sending this design and this spec, asking me to make it and price it, rather than saying, you know, do you get the opportunity to feed back design changes and say, you know what, like you mentioned here, this part doesn't need to be so shiny. We can make this quite rough because it's internal and no one's going to see it.
Like I say, it's back. It would be good to get feedback like that, but and this is cost saving. We don't need to sit there for, if it's got a fancy finish for 10, 12 inches, when we could be cutting that for maybe 20 minutes, we could do that in 5 minutes.
Yeah.
So there is a saving there.
The problem is that the people that you're speaking to have never been involved in the process earlier on in the stage. They've never had any, even just for a walk round of a machine shop to understand what things are and what they cost, would go a long way to helping buyers understand the process, to let them see, even to see how much it costs for a billet of steel, to be able to understand that as well. Because I think often, I know a lot of the feedback you guys give is that sometimes it's like, how can, when you lose out on a tender, how can somebody do it for that? Because the actual materials cost more than that in the first place. It's getting people to begin to understand that, isn't it?
I so Andy, are you getting faced with the same thing as well?
Oh yeah, yeah, absolutely. The pound can change anything, but absolutely. And you think, really? Okay, run along, because and again, you're right, mate. And I picked that up from you. Is that you sometimes, as much as hard to walk away from it. Okay, when you're looking for work to fill a machine shop, sometimes you're better just walking away from it, because you're not making any money at it. It's not good. You're better diverting your resources and time, working with the people and getting the jobs that you need.
Yeah.
Going back one step to the design side, you know, we're saying you're absolutely right. You know, is that, you know, you'll remember the days where, you know, you did have access to the design guy and you could phone him up and say, you know, can I ask a question? You know, that finish. Or then you turn around and say, oh, it gets painted. And you're like, why am I even turning it?
I know. I could probably count in one hand how many people that can actually phone it through to an engineer and say, right, do we really need this finish or whatever? And they will work with you. A lot of these guys, you're not allowed to even speak to them. You've got to go through the buyer.
I'm sure you faced it as well, where I delivered a part one time directly to the buyer. You know, they wanted it. I delivered it directly to the buyer, and they didn't even recognise it.
I can imagine.
Because they couldn't even. They went, I didn't realise it was as big as that. I'm going, well, it's on the drawing.
I think it's amazing sometimes when you get things like designed like that, and then they turn up and they're absolutely massive. You know, oh geez, I didn't realise it was that big. Why did we make it so big for? You know, the thickness of material or something as well. You know, we'll make it an inch thick. That's fine. And then you turn up, it's like, well, an inch is actually quite big.
Mind you, I must confess, I made a little wood burner for the back garden, you know, and I designed it myself and I made it myself. I nearly had to get a forklift in to move it like that.
It wasn't a 3D.
Maybe thick than the metal thickness.
It lasts forever.
It was never going to break, was it?
Nobody will be stealing that out of the back garden, that's for sure.
No. I think that the other part of that question before I was asking was the term design for manufacturability, I think, is quite important. So particularly when you look at the 3D stuff that, you know, you're talking about, Andy, is understanding the limitations of the equipment that we're using to make the parts and designing it to be suited to the machinery that we're using. You know, so for instance, you know, can the 5-axis machine physically do that, and why are we making such tight corners? For instance, you know, you can't machine out a square corner or a chamfer or something with some machines, and the same thing with 3D printing. You know, what are the limitations of the types of printer you're actually going to be printing on? Yeah, you can almost print any design in any shape, but it depends on the printer that you've got. You know, shrinking, stresses still are involved in 3D printing as well. You've still got to put in your chamfers and rounded corners.
Yeah, absolutely. Yeah.
I worked in Hydril a couple of years ago. Not that long ago, but it was a few years ago. And unfortunately, the Kuwaiti war started to kind of shut us down at the time because we were cutting drill pipe on big Cincinnati Milcron machines, and it was all going to the Middle East. And when the war started, the orders ended. But honestly, the stuff I learned in that workshop, from manual lace, I think it was a Colchester that I was on, up to the big Cincinnati milk rods. But I also loved doing phosphating, and I also loved doing the swaging, because we had a manual machine that you brought the pipe in to swage out the ID.
At the ends,
Yeah, but and it, obviously you get to learn your third-party inspection parts and all these kind of things as well. But it was the people that you worked with in the workshops that made that job.
Well, I can refer to that because the best training I ever did was I was 8 years at Tri-State where I started, and I couldn't have got a better training between manual turning, milling, cutting pipe, phosphating, in the engineering office, and everything. And it came back to I ended up back on the machines, which I enjoyed, and to manually manufacture these things, like just now, well, now that like premium threading, right? You can't cut one of these threads now unless you've got a license. It's got to be a CNC machine, which is calibrated. We were cutting these things on manual machines, nae calibrated, and hundreds of them in the 80s, and it worked. And now we've got all this specs and processes, which you need to be, obviously. But this is how you learned, and I think it's the basis of that makes you a good engineer as well.
Yeah, and that's exactly right. The apprenticeship path, even, you know, is the perfect way. You can ask questions and you're not expected to know the answers to. You can just ask any any silly old question, and that's your chance to learn all of that stuff. Get your hands dirty and do it. And that's one of the things that we're going to be missing out on with companies cutting some of these things at the moment, is we're not going to get those skills. We're going to get people sitting in offices trying to design, like you said, design massive structures on a computer, and they've got no realization of just how big something actually is in real life.
Yeah. Well, you're always learning in engineering. You're always learning. That's what I say to the guys. We're always learning every day, different things we come across that I've never seen. It's getting it. And for me, it goes in and stays in, and just something different that I've seen, even manufacturing or design. Because we get, obviously we're subcontractors, we see a lot of different designs of things, and there'll be copies of this and copies of that, but it's just how all the design goes together, and you learn from that.
Yeah,
Mike,
I worked as a reliability engineer in a refinery, and the worst thing you could do is sit in the office when they phone up and say it's broken and then send them the answer. You get out there when it's broken and you watch the fitters pull it apart and take it back to the workshop and follow them around and ask them questions, and they're the guys who know how to fix it, what's wrong with it, what the causes are. Learning it out of a book's no use at that point. So
I just love passing on my expertise and knowledge of the machining side of it. So I just passionate about machine. I love it. I love just getting on there and making a pile of swaff.
Yeah, no, absolutely. I think that's probably a good place to wrap it up as well. That everybody in this industry, the people on this call, thank you for taking the time to join in and passing on your expertise and that. But all of us are the people who are doing those industries and things. People need to phone you up and say, how can we do this better? How can we cut costs together rather than pushing those prices down, and work through the challenges and keeping it local and look at developing skills and things. So, to me, that's the way we get through it, is speaking to you who are the experts in your fields, and phone them up and get that expertise. It doesn't cost anything to make that phone call, and I'm sure you're happy to pass it on because it helps everyone. So
definitely,
thank you everybody else. Said thank you, Mike, as well for all of your inputs and preparing for this in time, and it was a really interesting conversation, and hope to see everyone again soon.
Okay, thank you, Matthew, for that.